Monsieur loses subscribers just because
I lose subscriber every time I put him on the thumbnail.
and Monsieur can't live stream anymore. You have like 999 subscribers.
There's more, if you will.
Alright, so
The only kid has a Bible.
So today we're going to talk about other functions. Yesterday I just want to recap everything. We went back to reciprocal functions. So okay, so yesterday we talked about y equal to x, y equal to x squared, y equal to absolute value x, y equal to x to the third, y equal to square root x. That's the very common one. Y equal to 1 over x, and that's kind of because kind of at the end. So yeah, so it's like a gang sign. So we talked about is going to be here, and this is going to be halfway. It's going to be a halfway. This is going to be a quarter way. This is going to be a quarter way. So the graph's going to be like something like this. So on this side, it's going to be like this, like this, like this, like this, like this, like this. So we say plug in a different value to try it. X, Y. I plug it in -3. It's going to be y equal to 1 over x, so it'll be -1 over 3. Plug in -2 is going to be -1 over 2. Plug in -1 is going to be -1. Negative half, so it's going to be 1 over -1 over 2. So if we keep changing flip, it's going to be -2. Same thing, that's equal to 1 over -1 over 3. That's equal to -3. So that's how you get those values. If you plug in 0, it's going to give you undefined. And if you plug in 1 over 3, it's going to give you 3. 1 over 2 is going to give you 2. 1 is going to give you 1. And then all the value 2 and 3. So that's going to be 1 over 2, 1 over 3. And then so that's come up with this. And then we talked about it looks like a gang sign. Yeah, gang.
Yo, where are you from? Yeah, gang. Yeah, gang.
So this function is actually called reciprocal functions. It's not called inverse. Please don't get confused between inverse. So reciprocal functions. So this gang is called reciprocal gang. It sounds pretty badass too. Reciprocal gang. Where you from? I'm from reciprocal gang. So this graph is gonna there is a we're gonna talk about domain on this function and there is range on this function. Domain is gonna be from -infinity to 0, not including 0, union 0 to infinity. This one's a hard one to know. And a range is gonna be from -infinity to 0, union from 0 to infinity. There is two asymptotes. There's a vertical asymptote. It's gonna be x equal to 0. So it looks like right here. How many of you guys have never heard asymptote before? What is asymptote? What is asymptote? How many of you guys have siblings? You do? Younger sibling?
I am the youngest.
I don't know if you ever have a younger sibling that come up to you say, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you.
That's the older one.
That's the older one to the young
Yeah.
Sophia. Sophia did that to you?
Sophia does everything to me.
Sophia, yeah. So like you're not really touching them. Like you keep on pointing out until like one person punch another person, then that's where you're actually touching occur, right? So you are getting so close and you never get there, right? So it's one of the things that you have to understand that there's a vertical asymptote. So if you keep on grabbing this line, then you're gonna say they might touching each other, but they don't. They are so close to each other, but they're not touching each other. So there was a horizontal one too. So there's a horizontal. And we're gonna talk about this a lot more. So it's gonna be y is equal to 0, and then you're gonna talk about this horizontal here. Then they'll say, okay, well, what we need to know here is this. When it comes here, there is an anchor point. An anchor point is actually, in this case, is actually not a point on the graph. So anchor point is 0, 0. It's where the asymptote intersect. So basically, the transformation is going to happen, it's going to move the asymptote. So that point is going to be the one that's moving. So once you draw the asymptote, once you draw that point, then you're going to draw the asymptote. And then you can go on from there. Okay, yes.
So the two like they never like touch like the asymptotes.
Yes, but the asymptote is going to move if you have transformation. So for example, it's 1 over x minus 1. So the whole graph is going to move right 1. But basically it's asymptote that's moving. So that's the things that you have to understand. So the asymptote is moving. Okay. Is this even or odd functions? Odd functions. Good. So that's odd functions. So you gotta make sure you understand that, odd functions. And you gotta understand, okay, so all those things, that can be one of the things. So we're gonna show you in terms of reciprocal function what graphing calculator goes, and I'm gonna show you more likely what the asymptote look like. Does it, any misunderstanding here? Like anything you don't understand before I move on? Okay. Then what I'm gonna do is I'm gonna go in the next part. So I'm gonna show you what the asymptote look like, because it's really important that you know asymptote before I go on to the next thing. So what a graph for asymptote? A lot of you guys have never seen this. So it's 1 over x. Is a screen? Is iPad like record the whole screen?
Yeah.
Okay, so this is the thing, right? This is a 1 over x graph. This is a gain sign. So you got y equal to x, and y equal to x, y equal to 0, and x equal to 0. So what I will do is I will change this to dotted line. I'll change this to dotted line. And then you see this asymptote. This is where the anchor point occur, 0, 0. So do you see that?
Mm-hmm.
And you see that this point that you might say, okay, what if I get to negative 100, right? So let's say if I go to like maybe negative 400, negative 1000. Okay, so you see like they are touching the x-axis. But if I zoom in enough, right?
Bruh. That's a lot of zoom.
It's a lot of zoom in, yeah.
Bruh. Bruh.
So they are actually not touching. It's a 1 over 1000, so it's 0.0001. So therefore, it's not really touching it. It just looks all awfully close, but it's not touching it.
So it never touched it.
Yeah.
That's
No,
crazy.
Okay, so that's the idea of asymptote. A lot of people a lot of teachers just kind of go over it, but you can actually see it, see what's going on. They're not touching that value. If you're touching it, then it's not going to be asymptote. So therefore, it's not touching it. And same thing happened on the vertical side. Same thing on this side, on the vertical. So there are two asymptotes, right?
Go to
So
3000.
Go to 3000. Okay, that's fine.
I don't
Let's
believe
go to 3000.
You're
Do you have the patience to go to like 10,000?
No.
You said
But if you go to 3000, if you keep on zooming, they're touching each other right now. But
What is this sorcery? Harry Potter. Harry Potter.
So does that make sense? So I used to make fun of kids, like the kid I really don't like in the class. I'll be like, you know, just like you and your relationship, but never get there.
Y'all, like, they need to
My
do
relationship is an asymptote.
He's like,
So yeah, but I don't think I don't like any of those kids here, so I'm not gonna make fun of y'all.
Wow.
So question about this part. So this is the asymptote, this 1 over x graph, but what's the next graph that we're gonna talk about, which is actually interesting. The next one is a pretty special. Next one is it's called exponential functions. But we can you have to start with a normal exponential function. So in algebra 2 they should cover this, but they probably didn't. So we're gonna cover something that's very similar to it, but it's not exactly. But in general, it's gonna look the same. So we're gonna cover the next function. It's called y equal to e to the x. Okay. Do you remember e? Do you remember the value e? Okay. No. What is e? What is it? Yeah, it's in the most beautiful equation. Huh?
But the actual value.
There's the actual value, yeah. Roughly 2.7 something. I don't know exactly. The number is roughly 2.71 something. Ariana, you might want to write this down because you can have something to go back to. So this one's kind of hard. That's why I asked you want to write it down. 1 over x, you should understand that too. That was kind of hard. So of all the functions, this first 6 function, this one's hardest one. I forgot to mention this one first. Let me mention this one. So this one's not what, I don't think this is on the parent graph, but I'm gonna start with talk about third root of x before I talk about that. So third root of x looks like this. Third root of x. Basically, I call them like an upstream, like a stream, like you go to the river, there's a stream, and you're going upstream pretty much. So if I did the xy chart, I want to make sure I plug in a number that can be cube root. So what's the number can be cube root? 8. So that's going to be -8 to -1 0 1 sorry, and then 0 0 1 1 8 and 2. Does that make sense? So then I will look like very much like this. So it's going to be like this one. It's this one. It's this one and this one. And this one. Yeah.
-8 be -2?
A -2. Yeah. Okay. Thank you. So then the graph's going to be like this.
That's cool.
So it's not a waterfall, but it's like an upstream. Okay, so like,
It's like the waterfall fell.
yeah, well, it's like upstream, like, you know. I don't know if you've seen like those fish can go upstream.
Yeah, yeah.
It's pretty cool. It's like one of those things can happen. They kind of like jump and get up there. And they have like, they can breathe right in the upstream. And I think salmon is the one. Salmon is the one that does it. Yes, salmon. Oh. Okay, so, but do you remember this graph looked like something else too? What does the graph look like?
The
Y equal to what?
X to the third.
X cubed. So I'm gonna do it in this part, so it's gonna be roughly right here.
That's why I'm saying it looks like the waterfall fell.
Yeah.
It's the same thing.
So it's gonna be like this, but it's different, right? It's gonna be like this. But what's the relationship between two graphs? What's the y equal to x cubed and y equal to third root of x? Yes.
Did you say that they're inverse?
They are inverse.
Yeah.
So they are inverse to each other, so they have a symmetry of this one. So you see that symmetry? And that's very important to understand. I don't think the cube root of x is one of the parent functions you really need to focus on. But it is something that kind of help you out, like you see the inverse of it, and you see the thing, because it really need to help you to see the y equal to e to the x, okay? So this graph, you probably assume the same thing. Domain is going to be from negative infinity to infinity. Your range is going to be from negative infinity to infinity. And it's even or odd function?
Even.
Odd functions.
Odd.
Because see that negative 2 and 2, they are opposite.
Oh.
So if you plug in opposite, it's going to give you opposite values.
Oh.
So that's odd functions. And then what else? What else? Anchor point. Anchor point is going to be 0, 0. And that's it. Nothing else can be added to this. It looks like a stream. So it looks like upstream. So I kind of have a name for everyone, so that way I can refer to something. Yeah.
What's so when it's an even function, how you know?
So,
Well,
because if you plug in like negative, right, for example, for parabola, you know, if you plug in a negative kind of, I guess, version of the x, it'll still give you the positive, or like.
Oh.
it's like your face, right?
Yeah, yeah.
This is symmetry, right? If you have ear on this side, you have ear on this side.
Okay.
Odd function is like you have eye on this side, you have eye on this side,
Yeah.
which is look like negatives, right?
A little bit.
You're right.
It's your thing.
So the next one is actually interesting because the next one is e to the x. Well, e to the x is in the most beautiful equation, kind of remind each other. So y equal to e to the x. E to the x, remember that this e to the I pi minus 1 plus equal to 0 plus 1. That number's plus minus whatever. But those are all special numbers, right? 1, 0. I is a special number because we just talked about that. Actually, I'm going to use lowercase I. Pi is a special number in geometry. E is a special number in mathematics. But what kind of math is involved? Well, exponential growth is very important though. A lot of you guys probably don't know this, especially a lot of your parents own a house. How many of your parents own a house instead of renting? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But most of the Asian people know this. But the people are, because Asian people don't like to overpay something. That's like a very traditional, stereotypical thing. So if you just can pay $10 and you're gonna say, no, I only want to pay $1. And that's if you go to traditional, like in the Asian cultural society, somebody's the tax is $10. You're gonna be like, okay, $10. You're gonna be like, you pay way too much. You start with $1 and you argue way up. Okay, so by the end you probably pay like $2. So that's in the Asian culture. But for the Asian culture, we know this because we're very stingy about money. At least I am. But for people who are not stingy, who are like doesn't care about number, if you pay the house, like you pay the normal payment, usually it's 30-year mortgage. 30-year mortgage is a totally rip-off. You pay almost a $200,000 house. You pay $400,000 at the year at the end, and almost if it's $200,000 house, you pay about $1,100 for the payment. The first payment that you're going to pay, only $50 go to the principal. Rest of the $10.50 is all go to the interest. So you pay double amount. So the bank making a good money from selling the house, making double within 30 years. Okay. So those of you guys, you should pay attention to your parents, but parents probably know this. You can actually do a bi-week payment. A bi-week payment is the same payment. You just take one extra payment per year. So you pay 13 payments instead of 12 payment. You actually can save 8 years worth of money, that's a lot of money. We're talking about $30,000 or $40,000 just by paying one extra payment per year. Okay, so those are things that you need to understand on math. For those of you guys that are gonna affect you most is actually the student loans. Don't ever borrow student loan. Ever. Student loan is a completely rip-off, and not only that, just kind of on a sidetrack, sorry. On a sidetrack, that student loan, if you borrow it, so I can buy $1 million house, right? And I can say I don't have money to pay. I pay the down payment, I'll just lose $200,000. And that's 20%. I can walk away. I says, you know, rest of $800,000 I'm not gonna pay. I can walk away and I'm gonna be okay. I just file bankruptcy. I'll just. But student loan are different. You cannot say I'm bankruptcy. I'm not gonna pay for it. You still have to pay for it. Not only that, once you get a job that you say I don't want to pay for nothing. Like my house payment, I didn't want to pay. I just don't pay. The bank is gonna take the house. That's fine. At least I don't have to pay $800,000 house, where the house is only worth $200,000. And that happened in 2008 to 2016. But what happened is you can actually the student loan is different. You can actually pay once you got a job, and if you say you're not gonna pay, they say we're gonna force you to pay. How do they force you to pay? Because student loan is really the government. Government can directly take from your paycheck. So if you make $100, they automatically deduct $20, boom. You don't even have a choice not to pay. But the thing is that they take $20 as the minimum amount of payment. So by the 30 year later, you're still paying something. It's worse, in a way it's worse than house payment. So they only take a minimum, they take a little bit at a time, and just keep on paying. And by the end of 20 years, you still owe like $400,000 for student loan for medical school, and you're like, why is that? It's not going down after they pay 20 years? No, it didn't. They take the minimum payments. And that's what happened with credit card and stuff like that, so that's very important. Y equal to e to the x is something like that. It's called exponential growth. So, and we can talk about that when we get there. So we said talk about x and y. But since we don't know what e is roughly 2.7 something, we're gonna assume an easier number to work with. So we're gonna assume a 3 to the x graph. It's really close. And if you can graph 3 to the x, this is roughly 99% close, 80% close to e to the x, which is that's what I want. I don't want anything more. So I'm gonna plug in -2. What happens is -2. I'm gonna get 3 to the -2, which is what? 1 over 9, right? And then you will plug in -1, so it's gonna be 3 to the -1, so it's 1 over 3. 0 is what? 1. And the 1 is going to be what? 3, and 2 is going to be 9. So this is a point that I want you to know. This is the anchor point. I'm going to use 0, 1 as my anchor point. So my anchor point is y equal to the e to the x is going to be 0, 1. Instead of 0, 0 is my anchor point. Sorry, I'm going to graph on this side. That's the reason why I want to do that. Y equal to e to the x. Okay. So, and this is the anchor point. Anchor point. It's going to be 0, 1. What else? I need to know? Well, I need to know that is domain and range. What is, so, first of all, let's plug in the graph first. So it'd be at -2 is 1 over 9. So -2 is right here. 1 over 9 is something like really close here.
Yeah.
1 over 3 is something like this, and then like this, and like this, I think, and roughly here, or more higher. So. But you also need to know if I were to plug in -5, what would be -5 be? If I would plug in -5, it's going to be what? 1 over 3 to the 5, which is 1 over 243, which is really awfully small. So it's so small that you think it's touching the x-axis, but it's not. Okay? So I'm gonna graph this. And I'm gonna graph this. So it's not a straight line. It's not 1/x graph. It has this, and this point here is a big point. We're gonna call it anchor point. Anchor point. And you see that domain is gonna be what? Well, obviously this is gonna keep on extend. It's gonna be very close, but it's not. So it'll be negative infinity to infinity.
Yep.
Range is gonna be, range on this one's gonna be careful. What is range on this case?
Parentheses 0.
Parentheses 0, yes. So you have a parentheses 0 to infinity, not a bracket, because you're not putting 0. And then your anchor point 0, 1. There's an asymptote. Where's the asymptote?
0.
Y is equal to what? 0 is a vertical asymptote, right? Y equals 0 is a vertical asymptote. And then there was anchor point 0, 1. There was no horizontal asymptote. So there's no horizontal asymptote. Okay? So this is a generalized the graph. It's even or odd functions. It's
Neither.
neither. So the next one I'm gonna do is, this is a very important graph to know in calculus, very important. You're gonna use it all the time. So the next one I'm gonna talk about, I'm gonna put it on the same graph because, or inverse to this, okay? So y equal to natural log of x. So remember the relationship of this one is the inverse. Okay? So although I don't know what natural log is, yes,
You said y equals 0 is vertical asymptote.
yeah.
Where is it horizontal?
Huh?
Where it can be a horizontal, because it can't.
Oh yeah, horizontal, yeah.
Yeah.
Thank you. Somebody I need to double check for that. So we're gonna talk about inverse of e to the x, inverse functions. Okay, so what happened e to the x inverse, natural log of x? And I don't know how to do it, but I'm gonna using that coordinate swap idea. I can swap them, right? So I can say, hey, if I don't know how to do that, I'm just gonna graph here. I'm gonna put on this side. I'm gonna say, hey, x and y. I'm gonna take it 1/9. It's gonna give me what? -2, right? Natural log of x. What are you whispering about?
Why is it ln and not log? Or is it the same?
LN.
Natural log is ln.
Natural log.
Okay.
We're gonna deal with natural log. If I have 1/3, it's gonna be what? -1, and 1 is 0. Again, this is the anchor point. 3 is gonna be 1, and the 9 is gonna be 2. Does that make sense? So I'm gonna create an inverse graph here, which is this point is the anchor point of each natural log of x. And this is not exactly value, this is just estimation of value. So because this is actually 3 to the x, is actually a log base of 3 of x graph. But we're gonna use that instead because it's somewhat very, very close. So at 1/3, it's gonna be -1. -2 is gonna be here all the way to, so it's gonna be something like that. 3, 1, something like that, and 9, 2, so something like that. So the graph's gonna be like this. So technically, this is not a natural log graph. This is actually log base of 3 of x graph, which is inverse of 3 to the x. But we're gonna use that because this is probably the closest estimation that we can come up right now, because we don't know those value and we need a calculator to generate those value. So this one is gonna be a symmetry. So symmetry. And so this one becomes a here. So what kind of natural log? So y equal to natural log of x. It has a domain is what? 0 to infinity. Your range is gonna swap, which is negative infinity to infinity. And very important to know is the natural log of anything less than 0, greater than 0, or between 0 and 1 is gonna give you a negative value. Anything above is gonna give you a positive value. Does any anchor point? Yep. It's gonna be 1, 0. Are we okay here? And then what we're gonna do is we're gonna say is that even or odd function? Neither, right? Neither odd nor even. What else?
X equals to 0.
X equal to 0 is what?
Vertical asymptote.
Vertical asymptote. Good job. Now, the only thing that's moving is this two. Pay attention. This is the only thing that's moving, which is this and the anchor point. So those are the things that's moving. Transformation-wise, that's the only two things that's moving. Yes?
They don't have to touch for it to be symmetry, or do
They don't have to touch. It's symmetry. They don't have to touch each other. No. Good question. Yes. All right. I'll see you after school if you need help on anything.
If I come for tutoring, I get extra credit for the test.
Yeah, but yours not a lot because like 5 point, 6 point.
I got it.